So in this next part, we're going to talk about the different ways to graph a quadratic. And we've already done one form. It was the 5.1 standard form, and it looked like this. So we had some number x squared plus some number x plus c. And we determined that the number that comes in front of the x squared is going to tell us if this graph opens up or down. And it's also going to tell us if this parabola is wide or narrow. So if this is a positive number, it's going to open up. If it's a negative number, the parabola is going to open down. If the number is bigger than 1, it's going to be narrower than the parent function. And if the number is a fraction, it's going to be wider than the parent function. We discovered that this number, the constant term, is going to be our y-intercept. And then the only thing that we could find useful for this number b is it helped us find the x value of our vertex, because we did the opposite of b over 2a. So if you're given an equation in standard form, there's some definite benefits. There's some things that you can just look at the equation and know this is the truth. This is how this works. So that's standard form. Today we're going to talk about intercept form. And intercept form looks like this. Y equals a times x minus p times x minus q. And we're going to come back to vertex form a different day. So what I'd like for us to do is look at this first problem, and then we're going to come back up here and make some general statements after we graph this first problem. So what I'd like to do is see if I can find the intercepts first. And I know that if I have a graph and I have a point on the x-axis, then that point is going to have some number for x and a 0 for y. So if I want to find the x-intercept where it crosses the x-axis, I'm going to start by putting a 0 where the y is. Now I have a problem like the ones we just solved. I have a factored equation set equal to 0. So if that's the truth, I know that one of these three things has to be 0. Either a negative sign equals 0, which that's not true, or x plus 2 equals 0, or x plus 4 equals 0. So x could be negative 2, or x could be negative 4. So what that tells me is I have a point at negative 2 for x, 0 for y, and a point negative 4 for x, 0 for y. So I'm going to plot those points. Negative 2, 0 is right here. So I just found the roots, or the x-intercepts, whichever one you want to call them. I just found the places where x would be if y was 0. Now I need to try to decide where my vertex is going to be. Some of you might already be thinking that you know that a parabola is symmetric. So I know that these 2 points lie on both sides of the line of symmetry. And if it's symmetric, the axis of symmetry has to be somewhere in here. So I have 1, 2, 3, 4, 5, 6 units in here. So if I go halfway across, so 3 units in between, I can find my axis of symmetry. So the axis of symmetry is at x equals 1. That means my vertex lies along that line somewhere. So I know that the vertex of this happens at 1 something, and then there'll be points on each side. I just have to find out what that something is. So I want to know what y would be if x were 1. So I'm going to go back to my equation, and I'm going to put a 1 where the x is. So I'm going to have negative 1 plus 2 times 1 minus 4. So I have negative 3 times negative 3, which is 9. So I know that my vertex is over here at 1, 9. put it right where I didn't need it, right in the way of all these numbers. So I've got a vertex at 1, 9. So my graph is going to look something like this. If I wanted to find more points on each side, I could have put 2 in here and found the point at 2. Also, I know that this happens like the parent function, so I should be going over 1, down 1, over 2, down 4, over 2, down 4. So let's do the next one, and we'll come back to this one. So if I want to find the x-intercepts, the first thing I want to do is make this equal to 0. So that means that 0 equals 2, or x minus 3 equals 0, or x plus 1 equals 0. We know that 0 doesn't equal 2, so that's out. So x equals 3 when y is 0, and x equals negative 1 when y is 0. So that means that I have the point 3, 0, and the point negative 1, 0. So what I just found were the roots, or the zeros, or the x-intercepts, they all mean the same thing, of this quadratic. So now I want to find the axis of symmetry. There are 4 units between these 2 points. So the axis of symmetry has to be halfway between. So my axis of symmetry is going to be at x equals 1. It's not like this every time. It just so happens that it's happened on both of my first 2 examples. So if x is 1, I want to figure out, so that means on my table of values, 1 should be right here for the vertex. I just need to figure out what the y value is. So I'm going to go back to my equation and put 1 in place of x. So I have 2 times 1 minus 3 times 1 plus 1. So it'd be 2 times negative 2 times 2, which is negative 8. So if I put 1 in for x, negative 8 is y. So I'm going to go plot that point. So my parabola should look something like this. And since there's a 2 right here, this tells me that it's going to be narrow. Instead of the parent function where I go over 1, up 1, this one's going to go over 1, up 1 times 2. And instead of 2 squared, which is 4, it's going to be 4 times 2, which is up here, 8 units away. So I have a point on each side that looks like this. So, just looking at these 2 examples, let's see if we can get an idea. What does this a value do? Notice on this problem, the a was 2, and on this problem, the a was a negative. On the one where it was negative, this thing opened downward. On the one where it was positive 2, it opened upward. This one was like the parent function. This one was skinnier, the parent function. So a for intercept form is going to tell us the same thing that a tells us on standard form. It's going to tell us if it opens up or down, and it's going to tell us if it's wide or narrow. Okay, what about these last 2 numbers? What are they going to help us find? I'll let you think for a minute. So if you said these 2 numbers are going to help us with our roots, you're right. Look at this one. This was a negative 3, and we had a root at positive 3. This was positive 1, so I had a root at negative 1. Here I had negative 4, I had a root at positive 4. Here, negative 2, or positive 2, so I had a root of negative 2. So once we solve for x, that's going to tell us our roots. Now, that'll change if I have a number in front of x, and we'll do one of those in just a moment.